NASA launched a possible breakthrough energy technology experiment. They launched a 12-mile long electrical conductor cable connecting the satellite and shuttle, called an electrodynamic tether, designed to collect high-energy electrons in the Earth's ionosphere and magnetosphere. The motion of the tether conductor across the Earth's magnetic field induces a voltage along the 12-mile length of tether. The voltage produced is expected to be up to several hundred volts per kilometer. If successful, the experiment could produce a lot of electrical power. If additional power is driven along the tether in the opposite direction to that which it normally wants to flow, the tether, in theory, could push, creating propulsion against the Earth's gravity and raise the shuttle's orbit. The advantages to this revolutionary technology in propulsion is that it does not require any rocket fuel. If successful, electrodynamic tethers could prove a way to greatly reduce the cost in space propulsion. For example, the International Space Station could keep itself in orbit, saving $2 billion in orbital reboost rocket fuel for every 10 years of the station's operations. But on February 25th, after the 12-mile tether began producing electricity, and an unexpected overload of electricity, fluctuating between 2 and 10 times that was predicted due to inaccurate estimates in the electrical charge of the Earth's magnetic fields, ionosphere, and cosmic radiation, fried the tether conductor, and it broke, severing it from the space shuttle.
The tether has broken at the boom. The tether has broken and is going away from us. Get it on the TV, Claude. Please get it on the TV.
Okay, we'll hold there a second. So this is the second time they've repeated this experiment. It's with a $250 million French satellite lost fuel to get to a higher altitude to release the satellite. They were trying to do it from a lower altitude using this tether. But I really think what you're going to see next is really what they wanted to do.
The tether has broken at the boom. The tether has broken and is going away from us. Get it on the TV, Claude. Please get it on the TV. The tether has broken.
In that call reporting that the crew can see the tether and see the satellite, that it's beautiful.
Kind of looks like a snow globe. They're all speechless. They're all new astronauts and command
This view
control.
showing
And they're pretty much speechless. No way!
the satellite. Again, just moving into sunrise. 81 nautical
Are you
miles now
serious?
from Columbia.
So they're new command control operators, they're new astronauts, they're not told what they're going to see, and they're speechless. Again, this is probably 90 to 100 miles away. The tether is all electrified, so it looks larger, I guess. Maybe it's because these things are all over it. That's a good one right there. We'll go back and look at that one closer.
You guys getting the image?
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angle. So there's a lot of stray light, and it's getting washed out quickly. But Claude is trying to do a quick, good job here adjusting the cameras.
That's a good one right there.
Copy that.
40.
You know, that description by the crew, this
That's
is
one we'll go
the
back and
tether
look at.
in the satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite are now just passing over the west coast of northern Africa. The two spacecraft
These
now
things Must
90
be
nautical
huge.
miles apart. Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
I should have my headset on so I can hear.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
So what we'll do here when this is over in a minute or so, we'll zoom in on a couple of those and look at them closer. First, I thought they were UFOs. This camera that he's using does detect near ultraviolet radiation, UV, so near UV. Most cameras nowadays do, even your cell phone cameras have a filter in there. They may not display the UV, but if you take the filter out, they'll show near UV.
Satellite now
So
100 nautical miles.
Charlie, completely unzoomed, and you see the full extent of the tether.
let's take a closer look. Okay.